my next question is on sheet metal. So whenever we are having various bend angles in the model, so defining the bend allowance is basically done through the bend table. So is there any simpler way of doing it, because it involves a lot of numerical input for the bend table?
Okay.
So is there any simpler way of doing this instead of using that?
Yeah, we can do that. Also, you are aware of that. We have introduced a multi-bodies option in the last time what we have released at 2010.
Yes, that's right.
I think you are using that, right?
Yes, it has been very helpful to me.
That's fine then. So let me show you what are the new enhancements that we have done this time in 2011. Now, for any contour shape from which I just create an edge flange, is easy to make use of this to create a patterns. I just select the edge here, and I want to go for a patterning this edge flange, which is no longer difficult for me to create. In fact, you can see that it's not only patterning the feature, even the individual bends have also been patterned. The same thing holds good even for a mirror command also. Just select the mirror, say about the right plane. That's how you end up with creating a mirror with a lot of easiness now, without having much difficulties in creating a pattern from the sheet metal features. Coming to your question that, when I just flatten this sheet metal, now in SolidWorks 2011, we can see the blank sketch from which you can get the development length that is required for estimating the amount of material required and also the cost. You can see it is approximately 191 millimeter. Inside SolidWorks, we have got various tools to define the bend calculations that can be done by making use of either the K factor or the bend allowance, bend deduction. But now in 2011, we have introduced something called bend calculation, which is mostly required for having a varied bend angles. Let's take a look into this. Say this is a table which I was mentioning. So this is how it looks. Say for each and every bend angle range, you will be having a definite and unique equations defined. So that based on the bend angle that the user defined, automatically the equation changes, and that's how it gives much more accurate result. This is how we can make use of this bend calculation inside SolidWorks now. Say I want to have a bend calculation table done here. I'll just say click OK for this. So automatically this bend calculation type of deducing the bend allowance is being incorporated inside sheet metal now. Let's say the flattened piece. If I want to check out this blank sketch, you can see that it's been reduced. It is now length is 189 millimeter. That's how we can make use of all these enhancements what we have introduced in sheet metal, basically for a sheet metal fabrication.
That's fine, Kiran. That's very good.
You know that, as I've mentioned earlier, you can make use of convert to sheet metal features that have additional options like, you can see on the screen, you can make use of gauge tables to convert into sheet metal, and also the rip edges and rip sketches is now converted to sheet metal as well. But open, but overlap and underlap rip types can also be defined in making use of convert into sheet metal now in 2011. So overall, I can summarize that by making use of these enhancements, what we have released in 2011, that really helps you out to support the enhanced for manufacturing. And also, by taking into this slide, you can see that how the performance and reliability has been increased from the previous version and the 2011 now.